Hello, members. We are proceeding with our series of thermodynamics as a lecture and as a field. And we have a question that we're asking ourselves. Is benzene used as an aircraft fuel? Because this is always a misconception with some people thinking that actually benzene is used as an aircraft fuel. So we shall find out that benzene is not used as a liquid fuel for aircraft because we know aircraft fuel requirements include high energy density, specific combustion properties, and safety considerations that actually benzene does not meet. So for that matter, we are going to give you a number of reasons that we think benzene is not used as aircraft fuel. So there is the one called the toxicity. Benzene is highly toxic and it is a known carcinogen. So prolonged exposure to benzene of humans can cause serious health issues, making it unsuitable for widespread use and handling in aviation. So this can result into cancers because of the highly toxic substances, carcinogens that are present in benzene. There is also high level of volatility. It has a high level of volatility because the high vapor pressure making it evaporate easily at normal temperatures, and this volatility can increase the risk of fire, explosion, and which is a significant safety concern in aviation. Furthermore, the energy density of benzene also needs to be studied. Although benzene has a relatively high energy content, it is not as high as specialized aviation fuels like Jet-A, Jet-A1, which are specifically formulated for optimal energy density and performance in jet engines. We also find out that we will discover that the major aviation fuels that are used shall be the Jet A and Jet A1 as we shall proceed ahead. But these are used because they have a higher energy density and of course they are good for optimal performance of jet engines. The combustion properties, obviously, aviation fuels are designed and desired to burn cleanly and efficiently at high altitudes and under varying atmospheric conditions. Benzene does not possess the necessary combustion characteristics required for reliable performance in aircraft engines. Now, what are the commonly used aircraft fuels? We have said we have Jet A and Jet A1, and these are kerosene-based fuels widely used in commercial aviation. They have high energy density, good combustion properties, and are less volatile than the benzene we talked about. Then there is AV gas, or that is the aviation gasoline, and this is used in piston engine aircraft. AV gas is a high uh, octane fuel designed to provide reliable performance in smaller aircrafts. For of course, like those small helicopters, helipads, you'll find that you are able to use this AV gasoline or the aviation gasoline. Then we have the biofuels. These are increasingly being used and developed, even tested for use in aviation to reduce environmental impact and reliance on fossil fuels. Now we wanted to uh, tell you that while benzene is a component of some fuels and used in chemical industries, it's not suitable to be used as an aircraft fuel due to its toxicity, volatility, inadequate performance characteristics compared to specialized aviation fuels such as Jet A and Jet A1. Now, what are the components of Jet A and Jet A1 fuel? We'll find that they have got The primary components are being hydrocarbons, but there are also various additives to enhance performance and safety. And the hydrocarbons that we are going to talk about are paraffins. The alkanes form the major component of paraffins, and these are straight chain and branched alkanes. These provide high energy content and good combustion properties. Cycloparaffins, these are aromatic hydrocarbons or cyclic hydrocarbons, the naphthenes, and these contribute to overall stability of fuel. The cyclic hydrocarbons contribute to the overall stability of the fuel. And we have also the aromatics, as we have already said, these are the ring-shaped hydrocarbons that improve fuel's density and lubrication properties, but must be kept within certain limits due to environmental regulations. The olefins, these are the alkenes. These are the unsaturated hydrocarbons, as we had earlier presented in one of our videos, and they are present in small quantities because they can be stable and cause deposits. What are the other additives that we add onto Jet-A and Jet-A1 um, so that they perform better or we enhance their performance? We have the antioxidants. These prevent the formation of gum and other oxidation products that can clog fuel systems. We have also antistatic agents. These reduce the risk of static electricity buildup, which can be hazardous during refueling. Of course, the presence of this hydrostatic electricity can cause sparks, and these fire sparks can later on germinate into dangerous and hazardous explosions that might take life and destroy property. Then you also need to have corrosion inhibitors. These are also additives that protect the fuel system components from corrosion. A basic example is what you always put in the coolant system for the engine. Of course, you always have these internal combustion engines. When you add the coolant, there is this specialized substance. If you add water, you find you have to add another coolant. And the major purpose also of the coolants is to inhibit corrosion. Otherwise, the engine might deteriorate with the time and reduce its lifespan. Then you have the fuel system icing inhibitors. These prevent formation of ice in fuel lines, particularly for those engines that work in very cold weather conditions. Yeah, when you have areas like USA, those other areas like Russia, where they experience winter conditions, in those times, you have to use fuel system icing inhibitors so that you prevent the formation of freezing, the formation of ice or freezing of the fuel. Then you have the biocides. These inhibit the microbial growth in fuel tanks, and this, of course, would result into blockages and later on corrosion. So now we want to also talk about the difference between Jet-A and Jet-A1. While both Jet-A1 and Jet-A are similar, there are some differences primarily related to their freezing points. The Jet-A1 are commonly used in the United States. Jet-A has a freezing point of negative 4 degrees Celsius, and it does not usually contain fuel system icing inhibitors as standard. So for it, you just use it the way it is, and you may not need to put this FC-II. What about the Jet-A1? They are internationally used, and they have a lower freezing point, making it actually suitable for using in colder climates and at high altitudes. Jet-A1 often contains fuel system icing inhibitors. So let us look at the summary of these components and the additives that we put in the aircraft fuels. We have said for the additives, we have the paraffin, which are the alkanes. Then naphthenes, those are the cycloparaffins. the aromatics, olefins, the alkenes, antioxidants, anti-static agents, of course, which reduce static electricity buildup, the corrosion inhibitors, which protect the fuel system components from corrosion and thereby breaking away with time. Then the fuel system icing inhibitors to prevent the formation of ice, the biocides that prevent the formation or the growth of microbacteria or micro living organisms. Now, members, let us also talk about the common fuels, and these common fuels include diesel, petrol, and gasoline. So, kindly follow us in the next lecture so that we are able to get the details about them. Thank you.